Here's another example of finding the model for a mean. In this case, we have a model with multiple indicator variables. So the model is that the mean number of flowers is a function of the light intensity and the timing, is some intercept, plus here's our first indicator variable, L300. We're told that's an indicator variable for intensity being or taking the value 300. And we can see there's a few of them, another 4 for different intensities. And then on the end we also have a term using an indicator variable indicating whether the treatment received the early light treatment. The first question asks us, what's the mean number of flowers when the intensity is 300? So we can write down what that is symbolically. We want the mean number of flowers. And we're told the intensity is 300, so we know that that light intensity is equal to 300. We're not told anything about whether we're talking about early or late light treatment, so this will be a function of the early variable. Okay, so we can go ahead and write down the regression model, filling in anything we know. We have a beta 0 plus beta 1. The first indicator variable here is L300. It's an indicator for whether the intensity was 300. We're working out it for a case where it was indeed 300, so it takes the value 1. Beta 2 times an indicator variable for whether the intensity was 450. It wasn't 450, so that's going to take the value 0. Beta 3, similarly, for intensity equals 600. Well, it wasn't 600, so that's 0. Same for 750, that'll be 0. Same for 900, that will be 0. And then we have beta 6 times the early indicator variable, and we're not told a specific value for that, so we'll leave it in the model as early. And then, of course, this simplifies down a little bit. We're going to have a beta 0 plus beta 1 times 1 is going to give us a beta 1. Beta 2 times 0 will be 0. Beta 3 times 0 will be 0. Same with beta 4 and beta 5, so they all cancel out. In the last term we'll have is a beta 6 times the early variable. Okay, so the mean number of flowers when intensity is 300 is beta 0 plus beta 1 plus beta 6 times early. So the actual value that mean will take depends on whether we're talking about the early or late treatment. Similarly, for the second question, we can get started by writing down what we want. We want the mean number of flowers. This time the light intensity is 150. And again, we're just going to leave the early variable in there. We don't know what value it takes. Similarly, we get started with a beta 0 plus beta 1 times the indicator that the intensity is 300. Well, it wasn't 300, so we're going to have a beta 1 times 0 plus. And similarly for all the other indicator variables, we're not talking about something that received an intensity of 450, that'll be 0, 600 will be 0, the 750 indicator will be 0, and the 900 indicator variable would be 0. So I'm going to write them all out in full, but they're all going to disappear. And then we have the beta 6 times early. Once again, that's going to simplify to beta 0 plus, all of these will be 0, we're just going to have the beta 6 early on the end. So the mean number of flowers when the intensity is 150 is beta 0 plus beta 6 times early. If we compare these two models here for the mean, so when the intensity is 300, we have a beta 0 plus beta 1 plus beta 6 early. When it's 150, it's beta 0 plus beta 6 early. So the only difference is this parameter beta 1. The difference in the mean number of flowers when the intensity is 300 compared to when it's 150 is captured by that single parameter beta 1.